Yadrava Vanua in Fijian means to watch over our environment and ancestral lands.
Our team is composed of three groups: the forestry team, the mangrove team, and the MRV remote sensing and GIS team.
And I've been working at a forestry team in collecting data, including tree measurements such as tree height and breast height diameter, NACA. We can use these data sets to support our novel machine learning, training, testing, and validation. We have incorporated the use of diameter tapes to measure breast height diameter and machine learning apps to measure tree height. We also measured crown cover for some trees during our fieldwork. This is a novel approach for calibrating and validating our analysis of high-resolution planet satellite imagery.
Coastal or blue carbon is an important priority. These blue carbon pools include seagrasses, mangroves, and tidal masses. Our project has chosen to focus on coastal mangrove and terrestrial forests.
According to our remote sensing assessment, the largest contiguous area of mangroves in Fiji is in our study area, which is from Bar River catchment and estuary, where mangrove forest covers approximately 5,071 hectares.
For our fieldwork, we went out to some mangrove forests to look at the stocking density of the mangroves as well as to assess the above ground biomass. Interestingly, much of the carbon sequestration in mangroves happened below the surface through the sediments. So to get an understanding of carbon sequestration, we need to take sample cores of sediments and assess these in the lab to estimate the amount of carbon that is sequestered in these ecosystems over time.
Our team used a range of different methods.
As shown here, we used Google Earth Engine in order to do a supervised land cover classification that incorporated NDVI, digital elevation models, slope, enhanced vegetation indices, Sentinel-1 SAR, and Sentinel-2 datasets. Next, our team made use of planet imagery.
Within this assessment, we used remote sensing satellite data from the planet imagery archives. This included the SkySat imagery collections with 4 bands.
So our measurement from the field can be used as input values that will be attributed to different forests and mangrove land cover classes in QGIS. We are often unable to monitor the mangroves and forests, particularly in remote areas that are difficult to reach. So our solution uses the space technology of the planet Sentinel and Landsat remote sensing imagery archives.
Our land cover classification and terrestrial mapping and mangrove forest inventories were undertaken in collaboration with local experts and Fijian communities. Using these participatory GIS research methods, it helped us to identify and differentiate between land cover categories, which is difficult to do using satellite imagery alone. This helped us to do measurement reporting and verification for categories such as shrublands, grasslands, croplands, primary and secondary forests, mangroves, of course, tidal marshes, and even seagrass.
Our prototype proposes to incorporate carbon modelling software. So having access to this high-resolution planet imagery allowed us to detect different levels of land cover change. This can have significant impacts on the accuracy of modelling carbon sequestration over time.
Unlike Sentinel and Landsat imagery, this planet imagery allows us to see and monitor each individual tree.
Our team's prototype intends to use published methods to train machine learning for identification, segmentation, and data collection for trees outside of forests in the Pacific. We have already commenced the machine learning training in QGIS. The prototype intends to visualize results using a GIS dashboard. This dashboard would include information about the projected tons of CO2 sequestered. We've also developed a website to visualize our results.
In terms of our plan for implementation, we have developed a detailed Gantt chart to show the coming 3 years and how this interacts with our various research and landscape restoration projects.
Through this co-design with the Ministry of Forestry, we have thought about MRV on REPAS areas and on riparian zone to maximize environmental impacts. By planting and maintaining trees along Bar River can help maintain stream banks, reducing erosion, risk of flooding and landslides. By supporting indigenous village communities to monitor their own forest in order to earn carbon credits, we can also support the livelihood of communities and indigenous connection to land.